hurts.
When Thomas Edison devised the first electrical utility system, there were no electric vehicles, air conditioning was still only used in a handful of places in the entire country, solar panels and wind turbines hadn't been invented, and the entire world didn't revolve around using electricity as a way to power our way of lives. So assuming that Edison couldn't predict all of these things that would happen, but let's not put it past him, he designed his electrical systems to work in ways that don't necessarily work very efficiently for the above-mentioned things. So this means we have to update our current power distribution system. The speech will inform the audience about what the smart grid is, what the benefits are, and the progress that is being made on the grid in the United States. As the world's population grows and our consuming of goods increase along with it, our grid becomes ever more important and at the same time stressed. On top of increasing demand, we are developing sources of renewable energy that give us another power generating source that we need to integrate into the power grid. The plausible answer to these problems is the smart grid. In essence, the smart grid is an updated and upgraded electricity delivery system. According to the Canadian Business Journal, the smart grid seeks to add two-way communication and control capabilities, allow power to be distributed more efficiently and reliably, and allow customers to use electricity more economically. It looks to increase the efficiency and affordability of electricity and its transmission. All these possibilities seem great, but what is the benefit and who will benefit most? According to an article in Issues in Science and Technology entitled, "Is the Smart Grid a Really Smart Idea?" U.S. generating plants have the capacity to make 16% more electricity than it will ever be required to produce, even on the hottest day in the summer, and this is costly and inefficient. There is also power generating plants that are designated just for peak hours operation, meaning they are only used during the highest demand periods, which may only amount to a few hours or days per year. This is extremely costly, and the plants and transmission lines have to be maintained when we hardly use them. All of these high costs get passed on directly to the customers in rates that they pay. The smart grid aims to be able to cut these unnecessary costs. It will also upgrade to a two-way communication system. Electric meters today allow no communication, and even the newer, smarter meters are simply a radio communication that allows for meter reading from a distance. A true smart meter in the smart grid will allow for constant communication between the utility companies and the customers in the form of variable electricity rates, current demand, among other information. Another facet of the smart grid will be the sensing and measurement technologies that monitor conditions of the grid. The technology could provide instant feedback dealing with a power outage, transmission line overload, or even sensing a current is carrying more electricity than the meters are reading, showing that a customer is stealing. The benefits of all this will be a more consistent power demand, lower rates for customers, and a more efficient way of transporting electricity. But how close are we to achieving this vision? According to the article Get Smart by Tom Arundale, which appeared in the journal Governing, a few of the nation's biggest utilities have begun integrating aspects of the smart grid. Pacific Gas and Electric has begun signing up customers for a smart rate program that charges variable rates depending upon the current demand. The company reports it cut power usage by an average of 17% on critical peak demand days. San Diego Gas and Electric is developing a local microgrid in the desert town of Bering Springs. The plan aims to equip 2,500 residents with interconnected smart meters, solar panels, backup generators, and a huge $3 million battery. Xcel Energy in Colorado is piloting a so-called smart grid city. It will have 60,000 customers connect appliances to smart meters and learn how to use a website to track power usage and variable rates. While these three programs show a great initiative and show the smart grid's plausibility, it will still be a number of years before we achieve what we imagine. We didn't develop a smartphone from nothing in a short period of time. It was a process and an evolution. This is what it will take to make the smart grid a reality, a long-term commitment. The smart grid is a response to the ever-increasing demand for electricity in this day and age. Our existing power grid will not be able to handle the demand and the integration of renewable energy sources. The evolution of our power grid will ideally allow for a more efficient transmission of electricity, along with a more economical way to distribute it. It will take some upfront costs to start the implementation of this evolution, but the long-term payoffs economically and environmentally will be well worth the price.